Hello class, welcome to Algebra Lesson 4.3, which is all about solving systems of equations by elimination. By the end of this lesson, you should be able to solve systems of linear equations using the elimination method. So this is part 2 of our lesson 4.3. Okay, so in part 1, we did like the easier elimination problems where you had a variable with the same coefficient. So if you had 3x in one of your equations, you had 3x in the other equation. Or maybe the same thing went for y, where your x's were different, but your y's were the same. So you had like minus 7y and minus 7y. So we practiced when you have those common things. Today we're going to talk about what to do when you have all different numbers. Okay, so we are going to start by looking at, we have 8x minus 2y equals negative 8, then 5x minus 4y equals 17. So if I were to add or subtract those two equations right off the bat, I'm not going to cancel either of my variables, which is always the first thing I want to do when I'm doing elimination. So instead, what I will do is I'm going to try to get one of these coefficients to match. So I'm just going to start by looking at my x's. I have 8 and 5. So I personally always look and say, okay, can one of these numbers go into the other? Can 8 go into 5 or 5 go into 8? And the answer is no, not nicely. Then if I look at my y's, I have a 2 and a 4. Well, 2 goes into 4. So what I want to do is I want to change this 2 into a 4. And the way I do that is I multiply it by 2. So what I'm going to do is I can't just multiply my y by 2. I have to multiply everything in the equation. So this is going to become a 16x and then minus 4y and then equals, and then don't forget to multiply all the way across your equal sign, negative 16. So now what I'm going to do is I'm going to look at these two equations, so the one that I changed down below, and I'm going to add it with the one that I haven't touched yet. So I see I have minus 4y, minus 4y. So in order to get that to cancel, what I'm going to do is I'm going to subtract both of the equations. So I have 5x minus 16x, which is negative 11x. Negative 4 minus a negative, that minus a negative becomes plus. So I have negative 4 plus 4, that's 0. So that the y's canceled, which is exactly what I wanted. Then 17 minus a negative 16, that becomes plus 16. So that becomes a 33. And then I keep solving from there. I say I need to divide both sides by a negative 11. Divide both sides by a negative 11. I have x equals negative 3. All right, so I've solved for one of my variables. Now I need to solve for the other. So what I'm going to do is I'm just going to plug it into one of my starting equations. So I have 5 times the negative 3 minus 4y equals 17. So I have negative 15 minus 4y equals 17. Add 15 to both sides, negative 4y equals, that's 32. Divide both sides by a negative 4. I have y equals negative 8. So then, just like always, we write our ordered pairs, or we write our answers as ordered pairs. So negative 3, negative 8, because you do x, comma, y. So that is my solution to the system of equations. And if I were to plug that back in, it should hold true. So I wonder if yellow will show up. So if I did 5, nope. If I'm going to use, there we go. So if I did 5 times, and then my x is negative 3, minus 4 times negative 8, I want to see, does that equal 17? This is how I check my answer. I'd say negative 15 minus a negative 32, or just plus 32 equals 17. So negative 15 plus 32, that does equal 17. So I get 17 equals 17. So I know my answer is right. Okay? These are problems that are easy to check if you got them correct. And if you were to plug it back into the first equation, you'd get the same thing on both sides if your answer is correct. All right, so now what I want you to do is I want you to look at and compare these two equations and see what do you have to change so you can solve using elimination. Good luck. All right, hopefully for this problem you ended up at -7.3. If not, please be sure to check the work that I have there, compare it with what you did, and be sure to ask for questions, ask for help by asking questions, okay? I'm more than happy to help you. All right, let's look at example 4. Solve a system of equations with infinitely many solutions and no solutions. So I'm going to kind of show you the fast way of being able to tell if two equations have infinitely many solutions, which, remember, that means that they are the same line. Like if you go back to lesson 4.1, I showed you how graphically infinitely many solutions is when you have multiple equations that are all the same line. And then no solution are those graphs that are parallel, right? They're the graphs that never touch. So since we're not graphing, what's the fast way of telling if something has infinitely many solutions versus no solutions, or having a solution? Okay, so if we look at this first one here, I have 8x minus 2y equals -8. I have 24x minus 6y equals -24. Now, right away, if I'm just kind of, powering through my assignment and I see this problem, I might start by saying, okay, I'm going to change this I'm going to try to get it to be a 6. So I'm going to multiply everything by 3. And so I might go like this and say, okay, I'm going to multiply everything by 3, and I'm going to write it over on the right side just because I ran out of room. So then I would have 24x, and then 3 times a -2 would be minus 6y equals, and then a 3 times -8 is -24. So then, once I multiplied and got those to be the same, you can see I ended up with the same exact equation twice. Whenever that happens, that's called infinitely many solutions. Okay? Then, if I go over here, you can see I have 9x minus 7y equals -15, and I have 9x minus 7y equals 17. I can tell this is a no solution because my values here, 9x minus 7y, are the same for both. Like these parts of my equations are identical, right? So those have to be the same number. Once you plug numbers in, those would be the same. But if I look over here, I have them equaling 2 different values, and that's just not possible. So whenever your x and y portion is identical, what you need to do is look at the value that's all on its own. So in this case, -15 and 17, and say, hey, those aren't the same. That means this is automatically no solution. Okay? And I actually just realized I want to go back a couple of slides and talk a little bit more. Let's say, I'm just going to make up a problem right now, okay? Let's say I have 3x plus 2y equals 12, and I have 5x minus 7y equals 10. Okay, so I totally just made up those numbers, but I did it so I could show you guys something. So you can see 3 and 5, 3 doesn't go into 5, 5 doesn't go into 3, 2 doesn't go into 7, 7 doesn't go into 2. When this happens, it's actually possible where you have to multiply both equations. So I can choose my x or my y. I can say, okay, 3 and 5. I can pick a multiple of 3 and 5, which in this case would be 15, right? They both go into 15. So I'd multiply the top by 5, and the bottom, to change that 5x to 15, I'd multiply by 3. So then the top equation would become 15x plus 10y equals 60. The bottom equation would become 15x minus 21y equals 30. and then my x's match so I could solve. So it is possible to have a system of equations where you have to multiply both of the equations, okay? So that is a thing, and I just wanted to make sure you were aware of it. But otherwise, once you get to this stage here, it's the same exact solving as what you've been doing, okay? So then let's move on to a word problem, because I know they're your favorite. We have a florist, is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? So I have the 5 roses and 11 peonies makes our regular bouquet. And mini bouquet, we have 3 roses and 5 peonies. So I'm going to write an equation that has to do with my roses first. So a regular bouquet uses 5 roses. A mini bouquet uses 3 roses. So I'm going to do 5x. So I'm going to say x is the regular bouquet. Y is the mini. So 5x plus 3y, because there are 3 roses in a mini bouquet, equals 118, because that's how many roses I have. Then I'm going to say 11x, because there are 11 peonies in a regular bouquet, plus 5y, because there are 5 peonies in a mini bouquet, equals 226. And from there, I'm going to solve. And this is just like that last thing I was just kind of showing you, where none of my coefficients are going to go into each other nicely. 5 doesn't go into 11, 11 doesn't go into 5, 3 doesn't go into 5, and 5 doesn't go into 3. So I'm going to have to change both of my equations in order to use elimination. So I'm going to change it so my y's cancel. So I'm going to make it so those are both 15y. So I'm going to multiply the top by 5. So I have 25x plus 15y equals 118 times 5 is 590. 590. And then 3 times x is 33x plus 15y equals 226 times 3, which is 678. Now I'm just going to solve it like I've been practicing all day. So I'm going to subtract these two to get those to cancel. 25 minus 33 is negative 8x. 15 minus 15 is 0, equals 590 minus 678 is negative 88. So I know x equals 11. All right, now that I have x, what I need to do is solve for y, the mini bouquets. So something that's really important is when you are solving, like plugging this value in to solve, you have to plug it back into one of the original equations, not the modified equation. So when you're solving for your second variable, plug it back into an original equation. So I'm going to say 5 times 11 plus 3y equals 118. And that would be 55 plus 3y equals 118. 3y equals 118 minus 55 is 63. And then I just have to divide both sides by 3. So then I have y equals 21. Okay, so that means I could make 11 regular bouquets and I could make 21 mini bouquets. And that is my final answer. Okay, so I made an equation for the roses. I made an equation for the peonies. I multiplied both of the equations, so I had something that canceled. Solved for x, plugged x back into an original equation, and then I got my new y value, and then I wrote my final answer. All right, so here's your chance to try a word problem on your own. It's the same idea, just slightly different. Good luck. All right, for this problem, hopefully you ended up at 8 regular and 15 mini. If you have questions about that at all, please don't hesitate to reach out and ask for some help. And then here is our last slide for today's lesson, which is just a nice concept summary showing you when to use substitution versus when to use elimination. All right, if you have any questions on anything from this lesson, please be sure to reach out for some help. Otherwise, have a great day.